Hi class, in this lecture here we want to begin our study of talking about integration by substitution. And this is a really important topic, especially if you're going to continue on into Calc 2 and Calc 3 and into further study in mathematics, because integration by substitution is one of the more common methods for integration when you get to a higher level of mathematics. All right, so we're going to just cover three things in this section. We're going to talk about how you use change of variables to find an indefinite integral. I'm going to introduce something called the general power rule for integration to find an indefinite integral. And then we're going to use change of variables to evaluate a definite integral. And I'm going to work a ton of examples in the coming slides. And what I'm going to do is I'm going to break this lecture up into multiple videos, okay? Just so it's not all one long, 2-hour lecture, okay? Okay. And what I'll do is, as soon as I'll introduce the topic, I'll explain it. I'll work a couple examples, and then once we get into some of the more harder examples, I'll start a new video so that it's a little bit easier for you to pause or break up the concepts and jump into something new. Okay, so this first one here, let's introduce the topic and then work some very simple examples. All right, so what we're doing with integration by substitution is what we're really trying to do is trying to find the integral of a composite function, okay? So something like this, f of g of x, okay? So we anti-differentiation of a composite function. All right, so here's the definition, and this is you'll see when I talk about going through the definition in the second part here. If you look back, we're going to do something called change of variables for this. Okay, so let's let g be a function whose range is an interval I, and let f be a function that is continuous of I. If g is differentiable on its domain and capital F is the antiderivative of lowercase f on I, then we have the following. If you're going to integrate f of g of x times g prime of x. All right, notice this is important. This g of x is the inside function, and I'm going to use inside outside a lot in the coming lecture, so this will make more sense as we get into the next parts. And on the outside of f here, we have the derivative of the inside. So really what you're thinking about is kind of like you're undoing the chain rule here, right? So this is equal to capital F, the antiderivative of lowercase f, evaluated at g of x plus c. Okay. And so the way we're going to solve this, so you're going to notice how I'm going to do this, okay? Or the trick to evaluating this. We use a change of variables. Okay. And so what we're going to do is we're going to introduce this variable. We're going to let u be the inside. Okay, so let u equal inside. Notice how I said over here inside. This gives, so what happens here is if u is equal to g of x, du dx is equal to g prime of x, or you putting it in differentials form, du is equal to g prime of x dx. And what you can do is you can substitute in. You can substitute in your change of variables. So instead of it being f of g of x, it's f of this u, okay? And this is okay because u is equal to g of x. In du, what we do, if you notice, du is g prime of x dx right here, all right? And that's just equal to f of u plus c. Okay, and I know it seems rather confusing right now. It definitely does. The first time you see this change of variables and this integration by substitution, it definitely seems a little weird. But I promise, as you're watching these lectures, as you see me do more and more examples, it's going to be really easy. Okay, and so the trick the trick to being able to figure out these problems is identifying the inside and outside function, okay, and then the derivative of the inside, as you see over there. Like, let me give you an example here. All right, so this is about identify pattern. So let's look at this. If you have the integral of 5x squared plus 1 cubed times 10x dx. All right, notice here, look, I have this cubed here. Okay, that's the outside part. I'm cubing something, right? So this is the outside. And what's inside or underneath the cube is this 5x squared plus 1. And then look, what is the derivative of 5x squared plus 1? The derivative is 10x. And look, so here we have the derivative of the inside. So it's about, okay, identifying the outside. The cube is the outside. The inside, underneath the cube, is this part right here. And then, hey, look, I have the derivative of the inside. Let's try this one. Let's look at the integral of the square root of sine of x times cosine of x dx. All right, well, look, think about this. Do I have something inside the square root? Yes. So inside or under the square root is sine. That means the square root is the outside function. And then, wait a second. What is the derivative of sine? Derivative of sine is cosine. So then I have the derivative of inside. That's what's going on here. I'm finding the inside, and then I'm saying, okay, well, what's the outside function? And then what's the derivative of the inside? This one's really interesting, okay? The integral of 4x cubed, all divided by 1 plus x to the 4th dx. Well, look, this right here, okay, this right here, you can rewrite this as 4x cubed times 1 plus x to the 4th to the negative 1 power dx. Well, look, I have something inside here, so this is inside, right? And then look, do I see the derivative of the inside? Yes. And then look, this negative 1 part is the outside. That's the outside function, so the reciprocal function here. Okay, so now what we're going to do here is we're going to use this once we've identifying the pattern here. We're identifying the pattern. Once we do that, we're going to use this change of variables. We're going to start letting u be equal to the inside, and then following through this procedure, changing the variables, and then integrating. Okay. So this also leads to what's called the general power rule, and we're going to use this a lot in the slides. You'll see. So if g is a differentiable function of x, then if you have, okay, g of x raised to the n power times g prime of x dx, well, that's just equal to g of x raised to the n plus 1 power divided by n plus 1. Or if u is equal to g of x, if you have the integral of u to the n power, you're going to see this a lot, okay? Okay, you're going to see this a lot in the coming slides. This is equal to u raised to the n plus 1 divided by n plus 1 plus c. All right. A lot. It feels like, feels like we're drinking from the fire hose here, right? And so let's get through. Let's now that we've recognized the pattern somewhat. Okay, we've recognized the pattern. Let's actually talk about how you evaluate these integrals now using this change of variables. All right, so let's go back and let's look at this first one. So let's evaluate the integral of this 5x squared plus 1 cubed times 10x dx. All right, so you're going to use change of variables here. Okay, the first thing you're going to do is you're going to let u be equal to the inside, okay? So this 5x squared plus 1. Now I'm going to differentiate this. So that means du dx is equal to 10x. And then I'm going to put in differential form. So this becomes du is equal to 10x dx. So now what you're going to do, all right, is you're going to substitute in the change of variables. So sub in the change of variables. And look, this is why we call it, and I'm just going to go back real quick in the slides here. This is why we call it integration by substitution, because you're substituting in this change of variables. So watch this. This becomes not 5x squared plus 1 cubed, but u cubed, because u is equal to 5x squared plus 1. And 10x dx, check this out, 10x dx, that's the same thing as du. Now this right here, boom, it's just the general power rule, okay? Let's integrate this. So this integrates as u to the 4th power, it's 3 plus 1, all over 3 plus 1, which is 4 plus c. And now here's your last step, okay? Now your last step, after you've plugged in the change of variables, is the problem wasn't in terms of u, it was in terms of x. So the final step, plug back in u is equal to 5x squared plus 1. So this becomes 5x squared plus 1 over 4 to the fourth power up here, sorry about that, plus c. And here's the crazy thing. If you take the derivative of this, to prove that this works, if you take the derivative of this, you get right back to this, okay? So this all works. So this substitution method works. Okay, let's now let's do the other two problems that we started with here. Okay, on the next slide here. So let's look at the integral of the square root of sine of x times cosine of x dx. Well, remember what we did. We said, okay, the sine of x is inside or underneath the square root. So I'm going to let u be equal to sine of x. And now I'm going to skip this going forward. So notice how I always do this second step, du dx, or how I did this second step here, not always. How I did the second step here, du dx is equal to 10x. I'm just going to skip and write it in differential form. So this is, what is the derivative of sine? Derivative of sine is cosine. So du is equal to cosine of x dx. So now substitute this back in, okay? So this is the integral of the square root, but not of sine, but of u. And then cosine of x dx, what's that? That's du. So this is u to the 1/2 power. And so now just, gosh, it's just that general power rule. This is u to the 1/2 plus 1 divided by 1/2 plus 1 plus c. So that's u to the 3/2 all over 3/2 plus c, which is 2/3, right? Because when you bring this up, you flip it. And remember, your last step, not u, not u, because our problem was in terms of x to begin with. What is u? U is sine of x. So this is sine of x to the 3/2 power plus c. And look, if you take the derivative of this, you're going to get this. Okay, let's now try this one. Let's integrate. And it was 4x cubed all over 1 plus x to the 4th dx. Okay, and so what I said here, going back, is we're going to let u be this inside part, 1 plus x to the 4th. That means du is equal to 4x cubed dx. Well, look, 4x cubed dx, that gets replaced by du, and this just becomes 1 over u. So this is 1 over u du. All right, and then what does 1 over u integrate as, right? So we've learned that that integrates as the natural log of the absolute value of u plus c. Well, last step, what was u? U is 1 plus x to the 4th. So this is the natural log of the absolute value of 1 plus x to the 4th plus c. And this is always positive, right? Because it's x to the 4th power here. So this is just natural log of 1 plus x to the 4th plus c. All right, so this is the whole process. Looking for something underneath or inside a function, let that be u, and then look for its derivative outside. All right, and so this will be the first part where we stop the lecture. And so what I'm going to do here in the coming slides is I'm going to work harder and harder examples. Like you're going to notice in the next lecture we do, things might not work out exactly perfect in terms of looking at something and spotting its derivative, but I'll show you that process. So I'll follow this up with the next part of this lecture.